Okay, just going through this, we're going to be looking at quadratic functions in vertex form. So with the quadratic functions in vertex form, what we're needing to do is we need to review your previous lesson. Now, I understand that more than half of you haven't done the previous lesson. That's why you have an F for today. I'm going to go through it fairly quickly, but I can't teach an hour lesson. I spent an hour last week going through this material and preparing that lesson for you so you could watch it. I'm not going to spend an hour explaining it now. So if you have difficulty following this, it's because you haven't done your homework. You haven't done Friday's class. So you'll just have to catch it up and watch the video afterwards. So a quick review for those that do understand. What we're looking at is what is the transformation of each of the three parameters here, a, h, and x, on the quadratic function. I'll give you a very brief introduction. So what we're talking about is we have the quadratic parent function, which looks like this. This is y is equal to x squared. Hannah, do you need to retake your test? You need to take that table and put it outside. And the chair. The parabola, the shape of this curve is called a parabola. The vertex of the curve, let me draw it again a little better, make the vertex in the right place. So this curve here is, this is y equals x squared, the quadratic parent function. The vertex of this curve goes through 0, 0. The characteristic point here is at 1 unit across from the vertex. So we go 1 unit across, like this. This characteristic point goes through 1, 1. We can use this point to see the effects of different transformations on the quadratic function. So the easiest ones, h and k. What you want to notice really carefully is that the general form of the transformations have a minus sign here. So the value of h is always the opposite of what it looks like inside the bracket. A lot of people get confused like this. So if we were to write y is equal to x plus 3 squared, what is the value of h at this point? Negative 3. Always the opposite of what it looks like because of that minus sign. So this is h is equal to minus 3. If we wanted to draw this function, a function like this one, let's take another example. We wanted to sketch the function y is equal to x minus 2 squared plus 3. We want to sketch this function. What's going to happen with this function? It's going to move. This function is going to be something like this. This is y is equal to x minus 2 squared plus 3. It's going to move across. Now it's going to move by the vertex, this point. This point moves. Now this point moves to exactly 2, 3. The vertex is going to go from 0, 0 to 2, 3. The whole function is going to go across and up like this one. And it's given by these two parameters, these called transformations. So h, this gives us a horizontal shift by h units. Now, if h is positive, we go this way. If h is negative, we go left. So if h were, in this case, h is plus 2, so we have a horizontal shift right 2 units. K is a vertical shift. By k units. Now if k is positive, we go up. If k is negative, we go down. So the coordinates of the vertex is always going to be h, k. This is the most important part. The coordinates of this vertex is h, comma, k. Now the characteristic point, this would be one across from the vertex. So what is the x value of the vertex? What is the x coordinate of the vertex of this second function? What is the x coordinate of the vertex? You can need to sit here, Marie, next to me.
0.
No. What is the x coordinate of this one? 2. 2. So what is the x value which is 1 across? Let's continue. Okay, so it's x minus h, remember? So the value of h is always the opposite of as it appears. So here in this function, h is equal to 2, k is equal to 3. So we are going to get a horizontal shift right by 2 units and a vertical shift up by 3 units. The characteristic point 1, 1 needs to be 1 across from 2, so it's going to be at 3. And it's being moved up 3 units. So we've gone up 3 units. So it's going to go up to from 1 to 4. Notice how it's gone up from 1 to 4. And it's gone up 3 units. Your last transformation is A. This creates a stretch and or reflection. So if h is greater than 0, if h is greater than 1, we get a stretch. If a is between 0 and 1, we'll get a compress. If a is negative, we get a reflection. I'm going to show that through a few examples. Okay, so that's a bit of a review of what we saw last week. Questions? So we need to sketch this without using a calculator. So what sort of transformations do we see in this one? Can we close the computers at the back? I need your attention, man. What sort of transformations do we see in this one?
Horizontal shift.
Horizontal shift? By how many units?
3 right.
3 right. Excellent. How do we see that? So we have h is equal to 3. What is the value of a in this one? 1. What is the value of k? 0. So we've got nothing added here at the end, and we're multiplying by 1 here. So we don't write the 1. That means all we've got is a horizontal shift to the right. So what would be the new coordinates of the vertex?
Horizontal h 4.
Not quite 4. It's going to go 3 to the right. 3, 0. This is always where you start. The coordinates here is h, k. H, k. The general form is y equals a bracket x minus h squared plus k. So we look at the function, we decide what the value of h and k is, and then we plot the vertex. So in this case, it's going to be at 3, 0. Do we have a stretch or compress? Why not?
Because a stretch would mean enlarging it, like Or maybe like adding a log to
Yeah.
another point.
How do we know there's no stretch? From looking at the function here and looking at the values of A, H, and K. How do we know there's no stretch?
Because A isn't one.
Because A is 1. That means no stretch, no compress, no reflection. So if there's no stretch, no compress, and no reflection, this point, which is 1 across and 1 up, stays at 1 across and 1 up. So from 3, 0, we go 1 across, 1 up, and it's going to go through there. This point you can reflect in the symmetry line like this. And we are going to get a function that looks like this. So if you need any more of these points, this is 1, 1 squared, which is 1, 1. The next one is 2, 2 squared, which is 2, 4, and so on. And you can just move them all across. With no stretch or compress, the shape of this curve should look the same as the shape of that curve. Okay, what is the value of A, H, and K this time? Value.
A is 1.
Nope. A is 3. What is the value of H? 0. What is the value of K? 0. If H and K are 0, what does that mean?
Stretch.
It is just a stretch. But if H and K are 0, what does that mean?
It doesn't move.
What doesn't move? The vertex doesn't move. So the vertex is going to stay here. Doing the vertex movement first is the easiest. Doing the vertex movement first is the easiest. So look at the vertex. It's the key giveaway for this function. Now, in this particular example, we have A equal to 3. What that means is we're going to get a stretch. So the characteristic point here at 1, 1, what will happen to it? It times by 3. It doesn't go 3 up. It times this by 3. So 1 times 3, we'll put it here. So this will be at 1, 3. So the y value is times by 3. That goes 3 up. We can reflect that in the symmetry line here. And then the next point up, which would normally be at 4, is going to be up at 12, right up there. So this is just going to go straight up like that. This is going to go straight up like that, really fast. Okay, what is the value of A this time? 1. What is the value of H? -2. This is the bit that causes most problems. It's a very simple thing. The fact that the general form is x minus h. So h is always the opposite of what it looks like to you.
Nice also, that want the H of the B, the negative B divided by 1/2 A, I think.
When you get to the top end of the generalized transformations in DE1, where you have horizontal compressions, then yes.
No,
But we're not using the B in this one. K is equal to 1. So for the quadratic one, we don't have to worry about the B, because the horizontal compression and vertical stretch are the same thing. They don't have any difference. So we don't use the B. Okay, what is the coordinates of the new vertex? Explain to the person next to you.
So it goes to the left. It goes to the left and 1 up.
I didn't see it. I think it's wrong to someone.
I think it's just you know what? So you just go final one, find the negative 2,
Okay, so what are the coordinates of the new vertex? What are the coordinates of the new vertex going to be? Sorry. Okay, what is the value of h?
-4.
No.
So
Look at the board. -2. What is the value of k? What is the coordinates of the vertex? The vertex is always going to be at h, comma, k. What is the coordinates of the vertex? -2, comma 1. So we go -2, comma 1. The vertex is going to go here. -2, comma 1. Edgar, take the input out. This is the value of h. -2. This is the value of k. Do we have any stretch or compress? No. So this characteristic point, which is at 1 across, 1 up, stays at 1 across, 1 up. It goes through here. We can reflect it in the symmetry line to here. So this one is going to go through here and here. You get a curve like this. Okay, write down for yourself what are the values of A, H, and K. Write it down in your book so I can come around and tick. Always use lowercase. Mac is case sensitive. So if I'm using lowercase, you have to use lowercase. It means something. Where's your pencil? Where's your paper? Sounds good. Have a look at it.
like one negative 1. Actually, people like to actually understand.
Write down about 3 numbers. Okay. The general cases to help you. On the first slide. Use the general form to help you. Y equals A bracket X minus H squared plus K. Try to do it yourself. So this is good. This is going to be minus that minus. Okay.
I say we need to do that?
This one is, this one's not.
Okay.
Okay, let's look at the answers. Not three. Okay, what are the values of A, H, and K? 2, -3, and K? What's the coordinates of the vertex? Very nice. So the vertex is always at H, comma K. That is -3, 0. Start by sketching the vertex. -3, 0. -3, 0. Label it. It's always your half your points. Now we have a stretch. So the characteristic point, which is at 1 across, 1 up, is going to be 1 across, 2 up, because A is equal to 2. It's not going to the value of 2 because A is 2. We need to take 1 and multiply it by 2. We take this 1, we multiply it by 2, and we get 2. So we go 1 across, 2 up. We can reflect it here. This one, which is so there's always 1 here as well. I don't know if you've noticed, I'm using it. 2 across, 4 up. That one's going to be 2 across, 8 up. So 2 across, 8 up, roughly about there-ish. So, let me try that again. It's going to look like this. Okay, what are the values of A, H, and K? Write them down. Please. After the lecture.
And then H0. K. Is that K or K?
What do we get for A, H, and K? Excellent. Is it this? This is wrong. So right, you want to write down the general form. Y equals A bracket X minus H squared plus A.
So there's one where those, or
Whatever number is X. Whatever's added at the end is your K. And then whatever is inside the bracket, and then square. So let's. Okay, you want to write down the general form. Y equals A bracket X minus H squared plus A. So A is whatever you multiply by X by. So what are we multiplying by? Let me write down the question. So you want to write down the question so we can see it. Okay. What are we multiplying by A equals X by? Is it 2 1 is 2? So A, negative 2. What are we having at the end? No.
What's 8?
So what is the charge inside the bracket? Okay, let's have a look. You want to write down the general form very clearly. You want to write down the general form. We're referring to this form. Y equals A bracket X minus H squared plus K. Now, A is always the number you're multiplying X by. What are we multiplying X by here? Negative 2. K is always the number you add at the end. K is always the number you add at the end. What number do we add at the end? 4. And H is the number you're subtracting from X inside the bracket before we square it. And there's nothing there, so this is 0. What's the new coordinates of the vertex going to be? Right. 0, 4. The vertex. The vertex is always H, K. So this is going to be 0, 4. Plot that first. So 0, 4. 0, 4. Now the value of A, we multiply the Y value with the characteristic point. Watch this one carefully. We normally go 1 across, 1 up. 1 across, 1 up. So this time, we're going to multiply that Y value of 1 by A. What will it become?
1 across negative 2.
Negative 2 up. What does negative 2 up mean? 2 down. Yeah. So we are going to go 1 across and then negative 2 up, or in other words, 2 down. So we're going to go there. Let's reflect that point over here. Put it there. And the one that normally goes 2 across, 4 up, will be 2 across, 8 down. Can we manage 8 down? 1, 2, 3, 4, 5, 6, 7, 8. Not quite. About there. So this curve is going to look like this. We have a reflection. Okay, last one of these. Write down what are the values of A, H, and K. If you can, have a go at sketching it yourself. Okay, what are the values of A, H, and K? Doof.
Negative 3 for
For which one?
1 for A.
A is 1.
3 for A.
Thanks, Mally. What, and K, Mally, what is that one?
K is 2.
K is 2. What's the new coordinates of the vertex? The new vertex is at 3, 2. 3, 2. It's going to be there. Do we have a stretch? Compress? Reflection? No. So the characteristic point is 1 across 1 up from this. So we go 1 across 1 up, reflect it in the symmetry line. 2 and 4 up becomes 2 and 4 up. So 2, 1, 2, 3, 4. Reflect it in the symmetry line. The vertex is going to be at 3, 2. Okay, so now we're going to do this backwards. There's the function. We need to figure out what the function is going to be. This one's a little tricky because we don't really get this point here, the 1 across. It's not giving you the 1 across. We can't use that 1 across 1 up technique. Looks like a half, but I'm going to show you another trick that we can do when they give you a value on the curve which isn't 1 across. It's further away. It's further away. So first up, this is going to follow they're all going to follow the model y equals a bracket x minus h squared plus k. And you start off by reading the vertex. What is the vertex of this function? Nope. Did you say 2, 0? Oh, that's not the vertex.
0.
Sorry. Hands up, Fab. Marie. 0, 0. The vertex is here. 0, 0. What's the value of h? 0. What's the value of k? 0. So this is y equals a x minus 0 squared plus 0. That simplifies to a x squared. Oh, sorry. So if the vertex is at 0, 0, it will simplify to this. And all we need to do is we take this point. This point is an x value and a y value, like this, 2, 2. We know that the function now is y equals ax squared. So 2 has to equal a bracket 2 squared. So 2 times 4 equals 2. 2 divided by 4 equals a equals a half. So this function is y is equal to a half x squared. You can see that now that that's 1 across a half up. 1 across a half up there, the characteristic point. What's the coordinates of the vertex going to be?
0.
Sorry, let me take somebody else. Let's see some hands. Let's see some hands. What's the vertex here going to be? Let me take somebody else. What is the vertex of this curve? 0, 0. What's the value of h and k? 0, 0. The vertex is at 0, 0. H equals 0. K equals 0. Y equals ax squared again. This is an x value. This is a y value. Put these into the function. Minus 8 equals a bracket minus 2 squared. What's minus 2 squared? It's not shown. What's minus 2 squared? Marina. 4. What's the value of a going to be? Solve this equation. solve this very difficult equation. I'll come around, write it down. We gotta go solving the equation. That's great. How are we doing?
What did she send it?
Is this the solution here? Yeah. Not quite, no. Do we get the solution? No. Divide both sides by 4. What did we get as our solution?
-2.
Where did we write it? So, divide both sides by 4. -2 is equal to a. This is the function y equals minus 2x squared. Have a go at these two for yourself. Work together with your partner. Yep. Let me pause the video a minute. All right, so in the first graph, what is the coordinates of the vertex? Right. The vertex is at 0, 0. What are the values of h and k? 0, 0. So we get y equals ax squared again. Okay, do we have a point? We have a point 1, 4. So we put in the 4 here, and we put in the 1 there. What is the value of a? 4. So a equals 4. This is y equals 4x squared. This time, we can see it's gone 1 across 4 up. So you can see the value of a that way there. 1 across 4 up. Let's try that technique here. We can see that this one is 1 across 1 down. So what's the value of a? -1. This is y equals minus x squared. Okay, have a go at the IXLs now. There's a video to explain number 5 for you. You can do number 5 and 6. If you haven't done last class, you need to start there because otherwise you're clueless, as many of you were today. Watch the videos for last class. This class and the previous class add together into the mini IA that you'll be doing as your homework assignment over the winter break. I will explain that to you next class. That's it for today.